Today we are going to be putting a lot of ideas that we've been building over the course of fifth grade together. So we're going to be relating fraction multiplication to decimal multiplication and also connecting this with place value. So I'm really excited for today's lesson, and I'm hoping and anticipating there will be a lot of aha moments where things will click that we've been learning. Also, I'm going to be showing you quite a few ways to think about things, and it's kind of up to you, as always, to try out the different ways and see which one makes the most sense and works the best for you. But I think that you will enjoy today and start to see things a bit differently and see how ideas that you've been learning are connected to each other. So say I want to do 0.1 times 4. And we know this 0.1 is also called 1/10 because the 1 is in the tenths place. So one way I can think of this is just doing 0.1 like with repeated addition, 0.1 4 times. So I'm going to do 1 time, 2 times, 3 times, 4 times. And I see that if I added them all up, I would get 0.4 or 4/10. I can also think of that as 0.1 times 4, and I get 4/10. If I wanted to connect this to fractions, I can think of the 0.1, the 1/10, and write it as a fraction, 1/10. And do 1/10 times 4. In fraction multiplication, I've been learning that I can write 1/10 times 4 as 4/10. And then if I wanted to write that as a decimal, I would write 4/10 as 0.4. I could also use a place value chart. And I could put my 4 down, which would be in the ones place. And then if I'm multiplying by 1/10, I've learned all the way at the beginning of the year that if I'm multiplying by 1/10, I bring the 4 over into the tenths place to show that it's times 1/10. And now I have a 4 in the tenths place, and I have to put my 0 and a decimal point, and I get 0.4. So we just thought of 1/10 times 4 in 3 different ways. We thought of it with a place value chart. We thought of the 1/10 as a fraction and multiplied, and we thought of it with repeated addition and adding the decimal together. And we got 4/10 each time. Let's get some more practice. Say I want to do 1/10 times 2. Well, with repeated addition, I can think of it as adding 1/10 2 times, and I get 2/10. I can also think of it as a fraction and rewrite my 1/10 as a fraction times 2. Think of it as fraction multiplication and write my product as 2/10. I can rewrite it back as a decimal by knowing that 2/10 is written as 0.2, 2/10. And then I can use a place value chart as well. I can put my 2 down in my ones place, and I know if I'm multiplying by 1/10, I bring it to the right 1 place value. And I put a 2 in the tenths place, I get 0.2. So each way I do it, either with repeated addition, with thinking of it as a fraction and then multiplying, or with a place value chart, I got 2/10 each time. See how they're all connected, the decimals, the fraction, and place value. Let's get practice now with a hundredth, but we'll use the same type of thinking that we were using before. So I can think of 1/100th times 6. One, I can think of it as repeated addition. So I'm doing 1/100th 6 times. So 1, 2, 3, 4, 5, 6. Ooh, let me make that more visible. And if I added it all up, I would get 600ths. I can also think of it as a fraction. I can write my 1/100th as 1/100th times 6. And we get 600ths. Which I can also rewrite back as a decimal. If I have 600ths, I know I can write 600ths as 0.06, 600ths. I can also put my 6 in the ones place using a place value chart. And if I'm multiplying times 1/100th, I'm not just going one place value to the right, I'm actually going 2 place values to the right. Because every time you go to the right in a place value chart, you're multiplying times 1/10 times 1/10. So 2 would be times 1/100th. And my 6, if I brought it over 2 place values to the right, would end up in the hundredths place. And I would have 0.06 or 600ths. So I did it with fractions. I did it with repeated addition, and I solved it with a place value chart. Okay, now we're going to do a decimal by a decimal, but we're still going to be thinking of it as both fractions and decimals to help us solve it. So I want to do 1/10 times 1/10. I can rewrite this. I can rewrite both factors as fractions. So 1/10 times 1/10. I've learned that when I'm multiplying fractions, I can actually multiply across, meaning I multiply the numerators together and multiply the denominators together to get my product. So 1 times 1 is 1 for my numerator. 10 times 10 is 100 for my denominator, and I get 1/100th. Let's see how this works using a decimal hundredths chart. But we're really going to think of this very similarly to how we did fraction multiplication. So I'm going to start by shading in 1/10. Here's my 1/10 going this way. And then I'm going to shade in 1/10 going the opposite direction, or going horizontally if I already did it vertically. I'm going to shade in 1/10. I'm going to add the orange a little bit on top so we can see, because we've learned in fraction multiplication that I can draw both fractions on an area model, and my product is going to be the part that's overlapping. So we can see that we have this 1/100th that's overlapping orange and green, and that represents our product. And the part that's overlapping with the 2 1/10ths is 1/100th of the whole. So 1/10 times 1/10 is 1/100th, as we can see in the model, that this part right here is 1/100th of the whole. All right, let's get a little more practice. Say I want to do 2/10 times 1/10. I'm writing each as a fraction. I can start by just multiplying across, right? 2 times 1 is 2. 10 times 10 is 100. So 2/10 times 1/10 equals 2 100ths. I can write that as a decimal, 2 100ths. I'm also going to show you on the chart, and I'm also going to show you using the standard algorithm of multiplication. So it's another way to think about it. So if I have 2/10, that means I'm going to shade in 2/10 on my chart. And then going horizontally, I'm going to shade in 1/10. Let me label what I have. I shaded 2/10 up here. I did 1/10 here. And then we want to focus on the part that's overlapping. So these two boxes are what's overlapping with the red and blue, overlapping with the 2/10 and the 1/10. So that represents our product. So as we can see, there are two 100ths that are overlapping. So 1/10 times 2/10 is 2 100ths. I also want to show you using standard algorithm of multiplication just so that you're seeing what's happening from different angles. So if I have 0.2 times 0.1, I can start in my place value furthest to the right. I'm going to do 1 times 2 is 2. 1 times 0 is 0. I can put a 0 down before going to my next place value. 0 times 0 times 2 is 0. 0 times 0 is 0. I can add them up. I get 2, 0, 0. I ignored the decimal point while I was multiplying, and then at the end I'm going to figure out where it goes. So I can see that I have one digit after the decimal point in each of my factors. Sorry. 1 plus 1 is 2. So I'm going to need 2 digits after the decimal point in my product. So I get 0.02 or 200ths. So we just thought of it in so many ways. We rewrote each decimal as a fraction and then multiplied the way that we know how to multiply fractions. We also used a decimal chart, when we used it kind of like an area model, the same way that we've been multiplying fractions, but we're just so familiar with this decimal chart, and now we're using it in multiple ways. And then I also used standard algorithm, and in each case we got 200ths. So all these ideas are super related. Okay. Going to do a few more because I really just want you to be able to see what's happening with these numbers. So I want to do 1 and 2/10 times 0.1. In this case, I'm thinking, since I noticed this number, my first number, 1 and 2/10, is more than one whole. It has a 1 in the ones place, not a 0. It's greater than one whole. I'm thinking this chart is not going to be the most helpful for me. I'm not going to use it right now because I would have to have more than one chart, and I don't think it's very helpful. It could be done, but like I've said, you want to use the strategies that make the most sense at the time, and I'm thinking that that's not going to be the most helpful strategy right now. But what will be helpful is to rewrite each of these as a fraction. So 1.2, 1 and 2/10, I can rewrite that as 12/10. Then I can rewrite my 1/10 as 1/10. And I can multiply across. So 12 times 1 is 12. 10 times 10 is 100. And I get 12 100ths, which I can write back as a decimal as 0.12 or 12 100ths. I also want to show you this using standard algorithm. So I'm going to line it up, 1.2 times 0.1. I'm going to ignore the decimal point as I multiply to start. 1 times 2 is 2. 1 times 1 is 1. I'm going to put a 0 down before going to the next place value. 0 times 2 is 0. 0 times 1 is 0. Add it up. And now I need to think about where am I going to put my decimal point. Well, I see that I have 1 digit after the decimal point in this factor, 1 digit after the decimal point in this factor. 1 plus 1 is 2. So I need 2 digits after the decimal point in my product. So my decimal point goes here. So I get 12 hundredths. So I got 12 hundredths when I multiplied them as decimals using standard algorithm, and I got 12 hundredths when I rewrote both as fractions and multiplied the way I know how to multiply fractions. So those are two different ways to think about it because decimals and fractions are so related. I'm going to do some more examples. If you're feeling ready to just go ahead and tackle this work, go ahead. If you want to stay on and see some more examples, this one is going to be interesting. We're going to relate it back to place value, and feel free to keep watching. So say I want to do 7 times 2/10. So one way I can do this is rewriting my 2/10 as a fraction. And then I can multiply the way I know how to multiply fractions by whole numbers. I can think of this as 7 times 2 over 10. I can think of that as 14/10, which I know I can rewrite as 1.4. 1 4/10. I could also use standard algorithm. I'm going to put 7.0 so that I can line up my numbers. 0.2, 2/10. Let me multiply. 2 times 0 is 0. 2 times 7 is 14. I see that my next digit is 0, so if I multiplied the 0 by everything, it's going to get 0. So I'm actually going to leave it, but I need to think about where I'm going to put my decimal point. So I have 1 digit after the decimal point in each of my factors. 1 plus 1 is 2. So I need 2 digits after the decimal point in my answer. So I get 1.40, which I know is equivalent to 1.4. 1 40 hundredths is the same as 1 4/10. So I'm going to put this in my place value chart for now, because as I go through this set of problems, this progression, I want you to notice what happens. So 1 4/10. Now I want to multiply 7/10 times 2/10. I'm noticing that the numbers in this problem are very similar to the last one. The main difference is this first factor is 1/10 the size of this factor. 1/10 the size. So I'm curious how that's going to affect the size of my product. Let's see what happens. Okay, I'm going to try it with fractions to start. So I'm going to write this as 7/10 times 2/10. I'm going to multiply across and I get 14/100ths, which I can write as a decimal as 0.14. I'm already noticing that that's really similar to my product up here, but the decimal point is moved 1 place value to the left. It's 1/10 of the size as the one in my first problem. Let me put that in my place value chart to see that even better. So for the second problem, I got 0.14. So we can see that all the digits were shifted over 1 place value to the right. So our product is 1/10 the size of this first product. Let's do the last one. I'm just using fractions for now. That's a good strategy for me. So I'm going to rewrite this as 7 hundredths. I'm going to rewrite the 2/10 as 2/10. So again, I'm noticing that one of the first factor is 1/10 the size of what it was in the last problem. So I'm thinking again, my product is going to be 1/10 the size of 14 hundredths. Let's see what happens. So 7 times 2 is 14. 100 times 10 is 1,000. So I get 14 thousandths. And I can write that as 0.014 to get 14 thousandths. I do not have thousandths in my place value chart, but we know it would go right here. I'm going to abbreviate. So if I wanted to put that in my place value chart, I would have to put 0.014. So again, we can see that all the digits shifted over one place value to the right. So every time one of the factors was 1/10 of the size of the previous, our product was 1/10 the size of the previous. So that was interesting. And it helps us think about how the size of our products relate to the size of the factors. But mainly, we really saw how, there's multiple ways to think about these multiplying decimals. We could use standard algorithm, the way that we learned how to multiply decimals. Or since we know fractions and decimals are so related, we could rewrite these decimals as fractions and multiply them the way we know how to multiply fractions. So we can really think of these numbers and think of what's happening with these multiplying decimals and fractions in different ways. So I hope that you had some kind of aha moment. I hope that you saw the interconnection between place value and decimals and fractions, so many things that we've been learning in 5th grade, and I cannot wait to see your practice today.